Okay, hello everyone. Welcome back. This is Mr. Kowald, and in this video, we're going to go over things you need to know regarding graphs and charts. So, in any science class, especially chemistry or biology, you're going to be doing labs, and those labs a lot of times are going to require you to do a graph or to do a table, right? You collect your data into a table, and you then put that data into a graph, right? So you're gonna analyze the data in a graph, but you collect it in a table. So here are some things you're gonna need to know about graphs, and these are typically what your teacher is going to require of you because this is good practice. The first thing is you don't want to have tiny graphs or tiny charts. You want to use all the space available to you. So that means that if you're given a full sheet of paper of, say, graphing paper, you want to use as much of that graphing paper as you can, right? You don't want to use one little corner of it or one little space of it. Use the entire graph paper that you are given, unless, of course, your teacher or your professor tells you something different. But typically, you want to use as much of that graph paper as you can. So when you're doing your graph, you want your x-axis to go all the way to the top. You want your y-axis to go all the way across, and you're using all of that space. So that way your graph looks nice. If your graph is too small, it's not going to look good. So just please, same with tables. Try to use as much space as you can. Second, use a ruler, right? So especially for best fit lines, if you're doing your graph by hand, then you're going to want to use a ruler so you can get those straight lines. Also, for your X and Y axis, you want to use a ruler to get that straight line so that way it looks nice. You want to put some effort and care into your graphs. So that's another thing. And so also when you're doing things like labeling your graph or whatever it is, or putting a title or things like that, labeling your axes, you want to please write clearly, neatly, large enough so people can read. You want to put your numbers and the increments there as well. And I'll go over this in more detail in a moment. Okay. So what's your graphing and data table your expectations? So one, you want it to be informative, right? So you want to make sure that you have the right information on there, that you want enough information on there that people can understand what the graph is about. So, for example, your title, right? What is this graph about? You want it to be descriptive, right? So you want to describe so the axes, you should have units down, right? What are the units that you're being measured on the axes? You have your x-axis and you have y-axis. You have your independent variable and your dependent variable and things like that. So you want to graph that. You want it to be descriptive, and you want it to be professionally done. That's the idea of like behind just making sure everything is done neatly and nicely. Again, using that ruler and just having good titles and good labeled axes. And again, I'll go over examples of this to show you exactly what I'm talking about. So here we go. So here is an example. You have a copy of this that was handed out, or if you don't, you can just follow along here. So here's a table, and you'll notice a few things about, I'm sorry, this is a graph, not a table. So you'll notice a few things about this graph. So first of all, it's got a very descriptive title. This is a great title. So you want a title that's going to be to clarify what the data is, what this graph is about. You don't want to label it something like graph number 1, graph number 2, something like that. That doesn't really tell you anything. So a good rule of thumb is to use what the axes are, right? So here, the axes are temperature and time. So then your title of your graph would be time heated versus the temperature of your sample, right? So we're it's a clear description of what is going on in this graph, what this graph is about. So that's the first thing. Second thing is you have labels on your axes. Your both axes are labeled. So you have the x-axis is labeled as time, and your y-axis is also labeled. Here it's labeled with temperature. So make sure your axes are clearly labeled. Okay, that's number 2. And number 3, notice that each of the axes indicates the unit that is being used. You got to have units on your graph. So units are very important. If we don't have the units, we don't really know how it's being measured and what the comparison is, right? So we got minutes for the time, and we have degrees Celsius. That little question mark, that should be a degrees sign. So that's degrees Celsius. So make sure you label your axes. And then also you have uniform scale, right? So what does that mean, uniform scale? You'll notice that each of the lines on your graph are equally spaced. And not only that, but you'll notice that each line has an equal increment, right? So notice that the lines that are perpendicular to your x-axis, look at the numbers on your x-axis. The lines are equally separated, and each line represents an increment of 5, right? So 0, 5, 10, 15, 20, right? So they're a uniform scale, and you'll notice that the y-axis has the numbers going up by 20. So 0, 20, 40, 60 degrees, 80 degrees, 100 degrees, and so on. And notice that if this graph would be the whole graph paper, this is not one part of your graph paper, that this would be the whole graph paper. So notice that you would label the numbers from 0 to 200. If your last data point is around 180, it's okay to go a little bit higher in your numbering, but notice that pretty much all the data points are covering the whole page of your graph paper. This is good. It's not tiny. It's not relegated to one little corner of your paper. It's taking up the whole page. So that is important to notice as well. So make sure that your scales are uniform, that each line represents an equal increment of measurement, right? So that's important. And also notice that the dots, the data points, are large visible data points. Don't put little tiny dots that you can hardly see. But at the same time, you don't want to make them like, extremely large. You don't want to be ridiculous about the size of your dots. But you do want the dots visible enough that it's easy to see what the data points are. Okay, so that's very important. Okay, so here again, if we're looking at this graph, the question is, what else is missing in this graph? We hit on a few things. What else is missing? If you said best fit line, you would be correct. So number 6, we need a line of best fit. What does that mean when you're line of best fit? A best fit line, or a line of best fit, is where you're drawing a line through the data points so that you have kind of an equal number of lines or data points on both sides of the line, but you're trying to get as many of those data points on the line. So basically, the line should be like the average of the data points. So some data points are going to be below the line, some data points are going to be a little bit above the line, some data points are going to be like on the line, right, or touching the line. So your best fit line is your basically your best attempt to getting like that line as an average of those data points. So this is something you're going to need to draw in. You don't want to connect the dots. That is a big no-no, right? So I shouldn't see, or your teacher shouldn't see where you're connecting the dots, like straight lines between all of the dots. That would be really bad. So your teacher would probably not accept that as a good graph, and you'll probably lose points. Okay, so don't play connect the dots. Okay, and your best fit line doesn't have to be a straight line. It depends on your data points. So here, it's obvious that the data points are curving, right? So if you try to do a best fit line here, it's just not going to look good, right? So if your data points are obviously doing a curving thing here, then your best fit line should also try to curve as well. Again, you're trying to get that average, and you're trying to get that where as many of the dots are going to be on that line. But again, you don't want to connect the dots, but you're just trying to draw that line that's going to represent like the average of that. So you just do the best you can with that. Okay, so best fit line can be a smooth curve. Doesn't have to be a straight line. And you'll have to be the judge of that. Okay, so not always linear. Okay, so now we're going to talk about tables. Tables, very similar to graphs. You need to have certain things that are important. So one, again, a descriptive title. So here again, you got mass and temperature data for heat transfer from unknown metal block to water. That is a great title. It's descriptive. It tells you exactly what that data is about, right? So it's not just table number one, table number two, figure number one, figure number. So you got to have a very descriptive title, and it's okay to have a long title like this because it tells you what the table is about. There's no ambiguity or confusion about what this data is. Okay. And so notice that labels, there are labels in every column. So again, labels are important. So columns and rows are labeled, right? So notice they'll have column number one is the sample number. Column number two is the mass of the metal block. Column number three is the mass of the water, and so on. And the rows are also labeled. So a lot of times you'll have different trials of your experiment or samples, and you'll call it sample or trial number one, trial number two, trial number three. That is very common. So that's the second thing to note. And the third thing again is units. So every column has units, or row. If your row is, if you're measuring in a certain unit and you have that in your rows, that's important too. So notice that the mass of the block, you have grams in parentheses. A lot of times you'll put the units in parentheses. So grams, so mass of the metal block is in grams, mass of the water is in grams. Your starting temperature of the water before you added the block was was a certain number of degrees Celsius. After you added the block, it was a certain number of degrees Celsius. So make sure you have your units for the data that you are collecting. And another data is written largely and clearly, right? So notice these are clear numbers. They're not really tiny. So again, making sure your tables are neat and legible and clear is very important because again, in science, the main thing why you do data is not only for yourself, but for the scientific community. If you want to present this, then you need to make sure your data is clear for other people to read, because if you publish a paper or if you present your work, people are going to want to see your data, and they want to make sure it's legible so that anyone can pick up your notebook and read it and understand what the data is saying. And then include decimals if possible, right? So again, this is going to depend on your measuring instrument. Your different measuring instruments are going to measure to a certain number of decimal places, and you want to make sure that you have the correct number of decimal places that your instrument allows. So if your instrument allows 2 decimal places, so for example, in the block here, we have 15.25, and you just write 15, that's going to be a problem, right? So make sure you write the proper number of decimal places that your instrument allows. Okay. So that's it for this video. Thanks for joining me. I hope this was helpful. If you enjoyed this video, if you learned from it, please make sure you subscribe to my channel. Hit that notification button on top. Smash that like button. Make sure you put a comment in the comment section. Let me know if you have any questions. And thanks for joining me. Have a great day.